our last two pieces. We're going to talk critical paths, and then we're going to talk about coloring vertices. Actually, I think we're going to skip coloring vertices for right now. We'll get coloring vertices next week. Okay, critical paths. Critical paths are actually used particularly by people in the construction business. Some of you I know work for construction companies. And so if I asked you, if you're going to build a house, can you start forming the walls, framing the house, if you haven't built the foundation? And of course not. You have to have the foundation first, then the walls, once you frame it in. Okay, once you frame it in, what can you do? Well, you may start to cover the outside with insulation and siding. There comes a point, however, though, when you're working on building a house, that more than one thing can go on at a time, particularly when you get to the interior. You could have somebody working on the plumbing, at the same time somebody else is maybe doing the drywalling. So different tasks can occur at different times. Well, if the person you're building the house for says, how soon will my house be done? How do you estimate how soon you'll have their house built? Do you go through and count the shortest amount of time each task is going to take? Or do you need to count the longest time? Because whichever task takes the longest, that's the one you've got to count. So critical paths are just the opposite of the paths we just did here. They are the paths that take the longest amount of time. So when you're going to do a critical path, it's the longest path between two vertices. However, you are trying to find the minimum time it's going to take to complete the task. So even though it sounds backwards, you're going to find the minimum time by doing the longest path. That's the case, because you have to get every task done, which will be the longest amount of time for each thing. Before you can do this, though, you have to build a graph of the situation, and that's what this chart is for. It tells you the task. So in this case, task S takes 5 minutes. Prerequisites means what has to be done before it, nothing. T takes 10 minutes. It also requires nothing in front of it. U takes 12 minutes, but you have to have T done first. And so as you get down farther down the list, W takes 15 minutes, but before you can do it, T and S have to be complete. So we have to build a graph of this situation and then find the longest path. You always start these at B for the beginning, vertex B, and you have to keep track of how many, in this case, minutes, beginning starts. Well, the beginning has no value, so we say it is 0. From the beginning, you branch off every task that has no prerequisite. So when you begin, you could go to S, which takes 5 minutes, or you can go to T, which takes 10 minutes. Okay, I'm making what's called a directed graph here by putting arrows on it to show that you have to go in that order. Okay, when you get to U has to come after T. So from T, we would draw over and say, okay, U has to come next. U takes 12 minutes. Okay, V has to come after U. So I would have another one. I just keep always working left to right. V takes 9 minutes. Okay, now is when it gets interesting. W has to come after T and S. So I have to find some place to put W where I can draw from both T and S. I'm going to just stick it up here on the top. W takes 15 minutes. It could come from S, or it could come from T. X has to come after U and W. So I'm going to do the same thing. I'm going to stick it over here farther to the right, put 14 minutes on it, but it could also come from U. So I can direct that up there. Lastly, we have task Y, which has to come after both T and V. Well, T's clear back here, but it does come after V, so I'm going to stick it out here, and there's no right or wrong way to draw these graphs, as long as you have them going in the correct direction. Oops, that's point Y, sorry. It has to come from V, but it also has to come from T. So I'm going to loop T back here, coming from that direction. Then, of course, if you had a beginning point, everything has to end. So any vertex you have left that's not going somewhere has to go to the end. And we always use end as 0. It takes 0 minutes to end, but we use the letter E. And so Y goes nowhere, so it has to go to the end. X goes nowhere, it has to go to the end. And there's my graph. Now I want to find the critical path, which is the longest path through the graph. So I'm going to start at the beginning and do the exact same thing I just did with the shortest path, except I'm going to try to make the longest number. So in this case, from the beginning, I could go to F. So I came from the beginning. I need another color here, hang on. So I could come from the beginning, which took 0 plus 5, so I'm now up to 5 minutes total if I add the 2. Or I could come from the beginning down to T, and 0 plus 10 would be 10 minutes. Then I'm going to go to W. I already at 5. 5 plus 15 more would make 20. If I came from T, I'm already at 10. 10 plus 15 more would make 25. So which one do I want? I want the longer one. So yes, I should come from T and be at 25 minutes. Okay, going to U, I have to come from T. 10 plus 12 would be 22 total minutes to get this far into the task. Okay, now X, which one will give me the longest amount? I'm at 25 up here. If I come from W, 25 plus 14 would be 39. That sounds big. If I check down here from U, where I was at 22 total, 22 plus 14 would only be 26. So that isn't longer. I don't want that one. But I do need to come over here to V, which would be coming from point U. 22 plus 9 would be at 31. If I go to Y, the longest one, 31 plus 9 would be 40. So I would be coming from V and I would be at 40 minutes. And then last but not least, when I go to the end, which one's going to end up the longest? I'm coming from a 39 or a 40, so 40 is longer, so I would come from Y, and it would take 40 minutes. So I know to actually get every job done and completely build or do whatever task this was, it's going to take me 40 minutes, and then you need to name the path it came from. So once again, we're going to backtrack the path. If we backtrack this path, we're going to be going from the end, which said came from Y, which came from V, which came from U, which came from T. So this is kind of boring, which came from the beginning. So it turns out on this one, the longest path is that one to get all of the jobs completed. So we would say that our longest path is the path that went from the beginning to T, to U, to V, to Y, to the end. And you have found the critical path, the longest path, which gets every task done. Guarantees every task on here would be completed. So that seems a little backwards, but it works. Okay, I was going to have you doing colored vertices today, but then I remembered that I have an activity you need to do first with me here. So we're going to do the coloring vertices at the beginning of class next time, and then you'll start your project. Your project, you'll be working with a partner. So I will see you on Friday, where we will take our fun and exciting final examination. If you all need to see me with questions, please, please, please catch me Thursday. Friday, you need to start it as soon as you hit the room, so don't think you're going to ask me questions at the beginning of class. So if you need me Friday morning, tell me to come early. Have a good day. You have this assignment to do, which is due on Tuesday, or you can work on your semester review sheets, whichever. Use the time wisely. Mrs. J will tattle on you if you don't.